Let us look into a more complex example. In this example, we have 136.4 kilograms of ammonia reacting with 211.4 kilograms of carbon dioxide to produce 168.4 kilograms of urea. The mass that is given to us of urea, the product, over here is the actual yield. Is the amount that the industry produces through this reaction that is given to us. It's not exactly what the amount is supposed to be, but it's the amount that they make from every reaction. We are asked to find the theoretical or predicted yield of urea and the percent yield for the reaction. They also asked us about the amount of excess reagent left over. So far, we know how to figure out the theoretical yield and the limiting reactant. Once we figure these out for this question, we can easily get the percent yield and the amount of excess reagent left over. To start off, we need to check whether the equation is balanced or not. It appears that our equation is balanced already, hence we can skip this step and move on to the next step. The next step would be to organize in a table the list of things that we know. Let us start by listing the reactants of the reaction. So, for our table, we have our reactants NH3 and carbon dioxide. Next, we are given our mass from the question, so we have our mass in grams. Now, if we look carefully into the question, we are given our mass in kilograms and not in grams. And we need all our masses in grams so that we can get our calculations done more easily and conveniently and get to our answers quickly. So we know that 1 kilogram is equal to 1,000 grams, which can also be written as 10 to the power of 3 grams. Or like, if one wants to ask, like, how do you know if it's 10 to the power 3, you can simply say that, oh, 10 to the power 3 is basically 1 followed by 3 zeros. Now we list down our masses. So we have 136.4 times 10 to the power 3 grams for mass of NH3. And then for carbon dioxide, we have 211.4, once again, times 10 to the power 3. Now that we're done with the masses, we can include the molar mass. So, molar mass, grams per mole. From the periodic table, we will have 17.031 for the molar mass of NH3 or ammonia, and for carbon dioxide, we will have 44.01. Next, we can calculate the moles, once again, either using the units that we're given, grams divided by grams per mole, or we can use the formula, moles equals mass over molar mass. And that will give us moles of 8.0089 times 10 to the power 3 for ammonia. And for carbon dioxide, we will get 12.4127 times 10 to the power 3. Next, we can figure out the ratio of the reactant with respect to the product. So for ammonia, we have 2 moles of reactant reacting to give 1 mole of urea. If you look into the equation, we have 2 over here and reacting to produce 1 mole of our desired product. So we will have our reactant to product ratio as 2 to 1. Similarly, for carbon dioxide, we have 1 mole reacting to produce 1 mole of the product, so we have a ratio of 1 to 1. Now, since we know the reactant to product ratio, we can clearly and easily figure out the moles of product that we can produce from each of these reactants. So for ammonia, we know the ratio is 2 to 1 from reactant to product, so the products that will be produced will have moles of half times the value that is over here. So let's say this value is A, so we'll have half times A. For carbon dioxide, let's call this as B. So we have a ratio of 1 to 1, it's the same, so we're going to have just B. Okay, now that we know the moles of our product, we can plug in the moles of the reactants that we have to get the moles of the product, like the actual values. So for ammonia, let's use a different color. The moles of product that will be produced by ammonia is going to be half times 8.0089 times 10 to the power 3, which is equal to 4.0045 times 10 to the power 3. Similarly, the moles of product produced by carbon dioxide will be equal to 1 over 1, because the ratio is 1 to 1, times 12.4127 times 10 to the power 3. And that will give us the same thing, which is 12.4127 times 10 to the power 3 moles. Now we can clearly see that the numbers speak for themselves. The moles of product produced by ammonia is far less than that of the moles of product produced by carbon dioxide. Hence, we can say that ammonia is the limiting reactant and carbon dioxide, on the other hand, is the excess reagent. And just like before, multiplying the moles of product produced from the limiting reactant ammonia by the product's molar mass will give us the theoretical yield of the product. So far, we have the moles of the product produced by ammonia, which is 4.0045 times 10 to the power 3 moles, and we calculate the molar mass of our product, which is urea, from the periodic table, and we found it to be 60.06 grams per mole. Now that we have the information that we need, we can calculate the theoretical yield of the product, or the amount of urea that was supposed to be produced through the reaction. So our theoretical yield in grams is going to be 4.0045 times 10 to the power 3 moles times 60.06 grams per mole. We end up with 240.51 times 10 to the power 3 grams. Now, since we have our product in the question in kilograms, we can convert this back into kilograms by simply taking out the 10 to the power 3, which is basically what makes the mass in grams. So we will have 240.51 kilograms as our theoretical yield. Now that we have the limiting reactant and the theoretical yield calculated, we only have the percent yield and the amount of excess reagent left over to find out. Percent yield is basically a measure of how much product is actually created with respect to the predicted or theoretical yield, which we have over here. According to question, 168.4 kilogram of urea was not supposed to be created, but it was the amount that the industry made instead of 240.5 kilograms. So that is actually the actual yield of the reaction, and the theoretical yield has been already calculated so far. So the percent yield of our product will basically be the actual yield, or the one from the question, divided by the theoretical yield, or the one that we found out just now, and then we will multiply this by 100% to express our ratio in terms of percent. So we will have 168.4 over 240.5 multiplied by 100%. And this will give us 70.02%. Now that is our percent yield. And now that we have found out the percent yield for the reaction, the only thing we now have left to figure out is the amount of excess reagent that's left over. The amount of excess reagent left over can be easily found with the help of the ratio between the reactants. So if we look at the reactants in this reaction, we have NH3 and we have CO2. So our CO2 to NH3 ratio, or the ratio to reactant, is basically 1 to 2, because 1 mole of carbon dioxide reacts with 2 moles of ammonia to give 1 mole of urea. Now, if we multiply this ratio with the moles of the limiting reactant, which is basically ammonia, this will tell us how much CO2 will be used up with ammonia. Okay, so figuring out the moles of CO2 already used up. This is going to be equal to moles of limiting reactant, which is going to be moles of ammonia times the CO2 to NH3 ratio, which is the moles of the reactants ratio. So we have 8.0089 times 10 to the power 3, which we calculated earlier, and then we just found a ratio to be 1 to 2. So we multiply this with half, and we end up with 4.0045 times 10 to the power 3 moles. Once again, using the formula moles equals mass over molar mass, we can figure out the mass of carbon dioxide used up, or we can also look at the units and then figure out our mass as well. So for the mass of carbon dioxide used up, we have 4.0045 times 10 to the power 3 moles multiplied by 44.01 grams per mole. Once again, we calculated this earlier. So our moles get cancelled out, and we end up with 176.236 times 10 to the power 3 grams. And now we can rewrite this as 176.236 kilograms. Now, this mass of carbon dioxide is the one that is completely used up or completely reacts with ammonia. What remains is the amount of excess reagent left over. So we reacted 211.4 kilograms of carbon dioxide in the beginning, and it appears that 176.236 kilograms of carbon dioxide was used up in the reaction. So we can say that the mass of carbon dioxide that's left over will basically be the amount that was initially used, which is 211.4 kilograms, minus 176.236 kilograms of carbon dioxide. So we can say that, therefore, m of CO2 left over is going to be equal to 211.4 kilograms minus 176.236 kilograms. And that is going to be equal to 35.2 kilograms. And that is the answer. Now, if we look back into the question, we will see that we have found out all the information that the question has asked us to find out. Once again, as an overview for solving stoichiometry questions, we check if the equation given is balanced, then we organize every single bit of information. And then we organize the information in the form of a table, and then we figure out the limiting reactant, the excess reactant, and using the moles of the reactant of the product. And finally, we use these bits of information to find out the theoretical yield. And once we find the theoretical yield, if the actual yield is given in the question, we can easily find the percent yield of the product. With the help of the ratio between the reactants, the moles of the limiting reactant, we can find out the amount of excess reagent left over. Every single stoichiometry question can be quickly and easily solved when these steps are followed. That is all for stoichiometry. Thank you for watching.